Hi dear students and viewers, welcome back to our channel Anvinay Kumar Basics of Physics. This is the right place to learn physics. Dear students, in this video we are going to discuss about one of the important topic in the chapter of semiconductors. So simply the classification of solids into the how many types on the basis of energy gap. Clear? So energy gap and energy bands. Based on the energy gap and energy bands, how we can classify the solids. So generally what we know, the matter can exist in three ways like solids, liquids and gas, like that. But we are discussing about the only solids in this chapter. Why? Because in any electronic device most of the materials are related to the solids. Clear? So here especially metals. Okay, now coming to the point. First we have to know about what is energy band. What is meant by energy band? Energy band is a group of energy levels of different electrons or different atoms. That should be called energy band. Simply you have to say the overlap of the number of energy levels. Energy levels of electrons or atoms, that should be taken as energy band. Clear? So all of you know the electrons are the responsible for the flow of current. In that especially the valence electrons in that particular substance are solid. In a solid so many atoms are there. In those so many atoms so many valence electrons are there. These valence electrons are the responsible for flow of current in the devices or metals. Clear? And next thing here what it is, everybody know, I think you have idea about the arrangement of electrons into the shells and subshells. Clear? So we know 1s, 2s, 2p, 3s, 3p, 3d, like that. We have sub energy levels are there, subshells are there, main shells are there. Some you have idea about those. Clear? So it is the one substance. In that so many atoms are there. So many atoms or group of atoms are there. Clear? In that again some electrons are there. Electrons are there. That's why one electron should be surrounded by these so many electrons in a solid. Clear? So for example this is the one atom and these are the valence electrons, and this is the another atom that should be having some valence electrons, and again same like this, again same. So these are the valence electrons in different atoms. So if you can take one particular electron, so for every electron some energy levels are there. So the energy level of this particular electron should be affected by the remaining valence electrons of different surrounded atoms of substance. Got my point? If you can take this particular electron, this electron is surrounded by the so many number of electrons of different atoms in the same substance. That's why here the energy levels of this particular electron should be overlapped with the energy levels of different electrons. So simply what you have to say, the energy levels of electrons should be overlapped. That should be what we call energy band. What it is called? Energy band. So dear students, again energy bands are divided into two types. One is the valency band and one is the conduction band. So first thing is what? Valence band. Next one is what? Conduction band. Clear? So valency band means where the valence electrons are available. Where the valence electrons are exist. That band is called valence band. And conduction band means what? That is the unfilled band. What it is called? unfilled band. Clear? So to identify that, I am drawing here. This is the, here now it is the valence band. What is this? Is valence band, and this one is what? Conduction band. And now here electrons are, these are what? Valence electrons. Valence electrons are there. Clear? So where the valence electrons available in that particular one band, that band should be what we call valence band, and which is completely unfilled, that is what we call conduction band. Conduction band. So children, before conduction, like that. After conduction means what? Moving of charges from one band to the another band, that is what we call conduction. The moving of electrons from valence band to the conduction band, what we call? Yes, that is the conduction. So after the conduction, the electrons are available in conduction band, and here some holes are formed. Holes are formed. So the formation of holes and how it can move, we will discuss in the next video. Okay, so simply what you have to say, before conduction, electrons are available in the valence band and conduction band is empty, and after the conduction, the electrons are where? In conduction band are there, and here now holes are formed, and in between these two bands some gap it is there, that is the energy gap or forbidden energy gap. What it is? Forbidden energy gap. Clear? So based on this forbidden energy gap only, we can divide the solids into the three types. One is conduction, next one is semiconductor, and third one is the insulators. Clear? So based on the energy gap only, the solids are classified into three types. What are the children? They are the first one, what is? Solids. Can classify like this. First one is what? Conductors. What we call? Conductors. Or you can write there like this. So classify into three types. One is what? Conductors, and next one is, I am going to say, insulators, and third one is semiconductors. So how the energy gap it is there in case of conductors? Look here now. So already this is what? Valence band, and this is what? Conduction band. So that means for conductors, what have to say? Energy gap is no gap. Energy gap is zero electron volts. That means simply what you have to say, in case of conductors, conduction band and valence band are overlapped. What we say? Overlapped. That's why easily the electrons are moving from valence band to the conduction band. That's why for conductors resistance is very less. Clear? When in case of a conductors, what you can observe, there is no energy gap. That's why easily the electrons can move from valence band to the conduction band for less temperatures also. That's why what you have to say, for conductors the resistance is very less. To understand in a daily life example, in a house, so many rooms are there. We can easily move from one room to another room, from hall to kitchen to some other room, bedroom, like that. So we can easily move that one. So there is no command to give anyone to move one room to the another room, like that. Simply all rooms are in a same house. Clear? Like that. Here there is no gap. That's why the electrons can easily move from valence band to the conduction band. Why? In conductors only the conductivity is more, means we have to say this one. First thing is what? There is no energy gap. That's why they can easily move from valence band to the conduction band. For less temperature, it is simply going on. If you give some additional temperature, it will take very fastly. So simply this is about the First one what is conductor. And now if you can go for the insulator, opposite to this one, that is what? So this is the conduction band and this is the valence band, and this is what? Conduction band. So dear students, here there is one line it is said, that is what I have to say, Fermi energy level. What it is? Fermi energy level. The electron will acquire some energy at the 0 Kelvin. That should be what we call actually Fermi energy level. What is meant by Fermi energy gap? The energy gap between the valency band and conduction band is called Fermi energy gap. In that Fermi energy gap, we will show one dotted line. That is the what it is? Fermi energy level. What is the definition for that? For which energy level the electron will go at absolute temperature 0 degree Kelvin, 0 degree or 0 Kelvin. At absolute temperature 0 Kelvin, how much the energy level of the electron should be there? That should be what we call Fermi energy level. So children, now coming to the point. Here, if you can take that the energy gap it is more. Energy gap it is more in case of insulator. So in insulators, energy gap is more. Energy gap it is more. So how is it is more? Almost all the energy gap is the more than the 3 electron volts. So here in valency band some electrons are there. Already energy gap it is more. That's why there is no possibility of moving of electrons from one band to the another band. At the same time, if you can give some additional energy, additional temperature also we can give. But the energy what it is given to the electrons, it is not sufficient to move from valency band to the conduction band. That's why in case of insulators, conduction is 0. Got it? In case of insulators, the energy gap it is more, and even though we are giving some additional temperature, the electrons are not moving from valency band to the conduction band, because the energy what we are giving, that is insufficient to the electrons to move from one place to the another. And here almost all the conductor is 0. That means what? The behavior of the conductors and insulators are opposite. Here there is no gap. Here energy gap is more. Here conduction is high. Here conduction is less. So here what you say? In this case resistance is less. Here resistance is more. Resistance is more or high. So that's why these two are almost all opposite. So now coming to the semiconductors. Some metals will behave. Their behavior should be in between the conductors and insulators. So here this is the conduction band and this is the valence band. So the energy gap what it is there, that should be more than the conductor and less than the insulator, That means what? In case of what we say, in case of conductors, energy gap is 0 electron volts. In case of insulators, 3 electron, more than the 3 electron volts. Now in case of semiconductor, the energy gap between these two is intermediate. So it is moderate like that. So in this case, energy gap it is what you have to children? It is less than 3 electron volts. So here the behavior of the semiconductor, this is what? Semiconductor. The behavior of the semiconductor is sometimes as insulator and sometimes it behaves like conductor. So at 0 Kelvin, there is no moving of electrons from valency band to the conduction band. At 0 Kelvin, in case of semiconductors, the electrons are not moving from valency band to the conduction band. That's why what you have to say, that semiconductor can be acts as an insulator. But at room temperature, the electrons can starts to move from valency band to the conduction band. That's why what you have to say, At 0 Kelvin it behaves as the insulator, and at from room temperature onwards it can behave as a conductor. That's why it is called as semiconductors. So children, so this is about the how the solids can be classified on the basis of energy bands. So I hope you understand. If you can understand this one, like, share, comment the video and subscribe my channel. In my channel I am going to upload all the MCET, NEET, previous exam questions and all the topics of intermediate questions. That's why you have to follow my channel and suggest my channel to your friends also. Okay, thank you for watching.